All right, everybody, we're working through the diploma prep material here. We're looking at the chapter on exponents and logarithms, and we're looking particularly at transformations of the exponential function here. So let's just take a quick look at this. We're supposed to describe the transformations that take this function to this function right here, and then we're supposed to identify the mapping and determine the horizontal asymptote. I like this question because it gives us an opportunity to chat about what's going on here and how the transformations really work. If you can see it in an exponential function, you really do get what's going on here. The confusion typically lies with the 1/4. Okay, remember that the 1/4 here is part of the original function. Okay, to be an exponential function, I need a base, and then I need the variable to be the x to be in the exponent here. And the base can be basically anything, except we are restricting it. We want them to be positive, and we don't want them to be 1. So really what we got to do is we got to take a look at what's inside the function here. So this is where it gets a little bit weird. To be inside this function, okay, means to be in the exponent. That's really how the exponential function works. So here, when we take a look at these, what's in the exponent here, this is where we're grabbing the horizontal transformation. So the negative in front here tells me that I've got a horizontal reflection going on. Whoops, sorry, you can't see that. The 2 means that I've got a horizontal stretch by a factor of 1/2. The +5 means I've got a horizontal translation 5 to the left. And that is all happening really within that exponential function. And then I've got this -3 out at the outside after we've applied the exponent. So because that's after the functional part of this thing, that's a vertical transformation. That's a vertical translation of 3 down. Okay. Now, the mapping is a description of what's actually going on with the individual points. Now, the mapping should reflect our description of the transformations. Okay. So a horizontal reflection means I'm putting a negative in front of the x-coordinate. A horizontal stretch, sorry, by a factor of 1/2 is exactly that. It's by a factor of 1/2, meaning I am multiplying x by a half. 5 to the left means I am subtracting 5 from it. And now the only thing that's affecting the vertical coordinate here, the y, is the 3 down, so it's going to be y minus 3. Now this question's asking, what happens to the horizontal asymptote? Okay, well, the horizontal asymptote on a exponential function that hasn't been translated, okay, the horizontal asymptote should be y equals 0. Now let's just think about this. Will a horizontal reflection flip y equals 0? If you got a horizontal line here and you flip it, no, that won't do it. Stretch a horizontal line by a factor of a half, well, no, that's not going to do it. Moving a horizontal line 5 to the left, well, it's infinite, so moving it 5 to the left won't do it. But moving a horizontal line 3 down, that will change it. So the only transformation here that's affecting that horizontal line is this one right here, and so therefore our horizontal asymptote will end up being y equals -3. Okay, so it's related directly to the vertical translation.